Ja, we staan bij de overweg in Oisterwijk. We hebben verschillende meetlocaties, maar Oisterwijk hebben we onder andere gekozen omdat we met een project bezig zijn dat heet STEM. TU Delft is gevraagd om een model te maken vanwege trillingen. Er zijn klachten geweest van omwoners en de Tweede Kamer heeft gevraagd aan de staatssecretaris om in de toekomst maatregelen te kunnen nemen. Ja, daarvoor moeten we zaken valideren en zijn we nu aan het meten.
So one of the key question we're trying to address is what causes these vibrations. So when you think of vibrations, you think of mechanical waves. Like any other forms of mechanical waves, it must has a source or origin, and then it must has a propagation path or transmission medium. In general, we have the three kinds of tests. One is we call pass-by measurements. So we measure the vibrations generated by the train passages. The second type of measurement is the in-track measurement. And the third type of measurement is the seismic measurement, which occurs within the field. That was carried out by our colleagues from geoscience department.
Met seismisch onderzoek kan je dus eigenlijk zonder schade te maken aan de grond een plaatje creëren van de grondlagen in dat gebied. En dat voorkomt dus dan dat we een gat hoeven te graven op de locatie om die grondlagen te bepalen. Nou, dit plaatje dat zegt wat over de opbouw van de grondlagen in de ondergrond. En in eerste instantie weet je niet echt welke laag welke grondsoort is. Maar door middel van aanvullende data uit sonderingen of CPT-onderzoek kan je dus een grondsoort koppelen aan een grondlaag. En dit zegt dan iets over de gedrag van geluidsgolven door de laag heen.
What we're doing here in Oisterwijk are actually three types of tests or measurements. The first measurement is this 3D scan. So we're using a handheld scanner to scan the surface of this insular joint to get an idea of the geometry, because this is the very important feature or characteristic of this insular joint. Another type of test is the so-called hammer test. So we're using a big hammer over there to give excitation to the track, and we record vibration signals using the accelerometers on the rail, on the sleepers, in the ballast, and also in the field. The third type of test is the ground penetrating radar. So we measure the underlayers of the track structure using this GPR, ground penetrating radar, to get an impression of the characteristics of what underneath the track structure. With these measurement tests, we could validate or provide input to the models that we're going to build for this project. Through the measurement data, we want to investigate what are the sources or what are the real reasons for the vibration problems. Is it because of the bad geometry of the joint? Is it because of the unsupported sleepers? Or is it because there's something in the transmission path of the vibrations? And as for sure, another insight we want to get is, are our models accurate enough or effective enough to predict these vibrations? If not, what are the areas to improve within these models? So ABA is short for axial box acceleration. It's a technique that we use to monitor the condition of the railway track. In this technique, we install accelerometers on the axial box of the railway vehicle. So when the railway vehicles are traveling along the railway network, we use the vibrations collected by the vehicle as an indicator for the condition of the railway track. I developed methods to predict or evaluate the track stiffness. So track stiffness is associated with a lot of problems within the track. One of the problems is the geometry. So when you have a variation of stiffness in the future, it can develop into a very bad geometry of the track. So it's useful to really measure the stiffness and being able to predict it, development of the stiffness in the long term. The idea is to constantly iterate even after the STEM program is finished. In the future, if you have a new problem to solve and you found new insights, you could always incorporate it into the STEM tool. So we hope it to be continuously renewing and ever-growing tool that can be used, I think, in the future, not only by the Dutch railways, but also the railway companies around the world.